So in this video, we're going to take a look at factoring a quadratic when it's in standard form and a does not equal 1. And in this case, a equals -1. When the a part of the quadratic, and again, I'll remind you, quadratics look like in standard form, they look like ax squared plus bx plus c. And so when this a value is a -1, I'm going to show you something special that you need to do. And the good news is it's going to be a little bit of a review of some of the other things that I've already discussed in my previous videos. So first we're going to try factoring out the -1. I've got -8h squared minus 13h plus 6. If you don't mind, I'm just going to replace the h with an x. So this will be positive 8x squared, because I factored out a -1, and then it'll be positive 13x, because I factored out a -1, and then this will be minus 6, because I factored out a -1. All right, now that I've got that, now I can go ahead and factor this guy using the x method. The number on top here is going to be 8 times -6, so that'll be -48. And then the bottom number will be positive 13. And then we got to find numbers that multiply together to get us 48 that add up to 13. So we're going to make a list of all the factor pairs of 48, and that'll include 1 and 48. 1 times 48, that's 48. But 48 minus 1 is never going to get me 13. Then we could try 2 and 24. That'll 24 minus 2 is 22, so I'm still not at 13. And then maybe we could try 4 times 12. That'll get me 48. 4 and 12 is 16. Close. 12 minus 4 is 8. Not quite. It feels like I'm missing the two numbers that could get me 13. And it's possible that there are no two numbers that get me 13. And if that's the case, we would say that this quadratic is not factorable. But I'm going to show you a little trick. I'm going to remind you something from the old days. We're going to try to find the prime factors of 48. And we'll do that by making a factor tree. We'll divide by 2 and then you get 24, divide by 2, and then we get 12. And then we could divide by 2 again, or we could divide by 3, either way. But divide by 2, we get 6. Divide by 2, we get 3. Now, when you're doing a factor tree, you're not always dividing by 2. It just turned out this was a number that I could divide by 2 many times. Sometimes you'll divide by 3 or 5, or any prime number is a good thing to try dividing by. Anyways, what I'm discovering by breaking this down into prime factors, I can see that aside from these guys, one way to get a pair of factors for this situation is I could do 2 times 2 times 2 times 2, that's 16, times 3. Aha, the missing pair of factors that I was looking for. So I'm going to go ahead and put 3 here and 16 here. And then I'm going to hope I can make the signs match up. If I take away 3 from 16, I get positive 13. And if I multiply -3 times 16, I get -48. Hey, this looks like it could work. There's only one little trick. In my previous video, I said when you have a number out in front of the x squared, you got to divide this guy by that number, and you got to divide this guy by that number. Again, I told you this would be a little bit of a review from the previous video. Let's see here. So then let's do this. After you get that, if possible, you will reduce. And if possible over here, you will reduce. And so let's go ahead and write those guys out in their reduced form. -3/8 can't be reduced, so it's -3 over 8. And 16 over 8 certainly can be reduced down to 2. And just to be safe, I'll make that 2 over 1, because I'm about to write out the factors and I want you to see how I got them. So let's give it a try. So I'm going to write out 8x minus 3. And I'm going to write x plus 2. And some of you folks might be wondering, where'd that come from? Well, when I'm doing this factoring procedure, the -3 over 8, the 8 on the bottom, the 8 will be multiplied times x, and then you add the -3 to that. In this case, adding a -3 is like subtracting a 3. Again, here you take the number on the bottom and multiply times x. 1 times x is just x. And then take the number on top and add that to the other two. And that's how we get those factors. I would also like to remind you, I'm going to go ahead and get rid of those arrows. Let's see if I can get rid of those red arrows. And I'm going to remind you guys that originally I had factored out a -1. That still belongs. And that should be the factors that represent this original quadratic that I started with. These two should be equal. And one way that I could test that out and check is I could FOIL these two together and then multiply everything by -1. And if I do that, I expect to get this. Other than I got to convert the x's back to h's. Okay, I wanted to show you another way to factor quadratics when they have a equals -1. I did it. I hope it was helpful.